We're going to spend just another day reviewing how to graph linear equations in slope-intercept form because I feel like we need to hear all of this information just a few more times. So let's zoom into the steps here. The first step when we're graphing linear equations is to plot the y-intercept. Now we can only find the y-intercept when our equation is written in y equals mx plus b form. Because, like is highlighted on your paper, the b is the y-intercept and the m is my slope. So if it is not written, the equation is not written in y equals mx plus b form, we'll have to rewrite it into that form. We'd have to solve it for y. But for this particular question, we already have it in y equals mx plus b form, so we're going to grab the y-intercept of -3 and we're going to plot that y-intercept, which means we're going to go on the y or up and down axis, and we're going to go to -3, and we're going to put our beginning value. Then we're going to use the slope, the m value, the rate of change, to plot more points. So once the slope here, which was 2/3, we know that that means from each coordinate that we've graphed, we're going to go up 2 units and we're going to go right 3 units. So watch this pattern happen on your screen. We go up 1, 2, and over 1, 2, 3. We put another coordinate there. That pattern repeats across your graph. 1, 2, 1, 2, 3, 1, 2, 1, 2, 3, until you can draw that straight line through all the coordinate points. And then to make your teachers happy, you're going to end your line with arrows to designate that the line keeps going forever and ever and has a domain and range of all real numbers. That's it. That's all you have to do to graph the line. But some other things we're going to go over is the vocabulary associated with this. When we're talking about the slope, we're talking about the m from y equals mx plus b. We're talking about the rise over the run. It's like the angle that the graph takes, the incline of the line. The y-intercept is the b value from my y equals mx plus b formula. This is where the graph crosses the y-axis, where the graph or the line crosses or intersects the y-axis. It is a coordinate, so you may see it written as 0, b, or just the value b. Now, y-intercept is a location on the graph. When we're given word problems, we're going to call this point the initial value. So when I ask you for initial value or the y-intercept, both of them are referring to that beginning value or the place where the graph crosses the y-axis. The other vocabulary we're going to deal with today is the x-intercept and 0. These are not seen in the y equals mx plus b formula, but they are locations on the graph. They mean the same thing. They're going to occur where the graph crosses the x-axis. There's a coordinate, boop, right there. That is where the line crosses the x-axis, the x-intercept, or the 0. We have 4 vocabulary words, but only 3 places on a graph we have to look for them. Slope, or rate of change, is the rise over the run. The y-intercept, or initial value, is where the line crosses the up and down, or y-axis. It's our beginning value. The x-intercept and the 0 are where the graph crosses the x-axis, which is the flat axis. Easy. They're just places we look on the graph. So let's try one together. If we go to the inside of your notes, we just have one problem we're going to be graphing together. It says to graph the following. We have 2x plus 4y equal to -20. Can I graph this equation exactly how it looks right now with the tools that you know how? No, so far we've only learned how to graph in y equals mx plus b form. Where the b is the beginning value, or the y-intercept, and the m is my slope. If your equation is not written in this form, right now we have to solve for y before we can do that. Not a big deal. We've been practicing solving for y for a while. So we start off by just moving the x term across that center line. Bloop. When it crosses the line, it changes the sign. Don't do too much. All we do at this point is rewrite the equation with all three pieces showing 4y equal to negative 2x minus 20. We're going to divide by the coefficient of y and then actually do all those division problems. We're going to have y equals negative 2 divided by 4 is negative 1 over 2x. Negative 20 divided by 4 is negative 5. Great. It is now in y equals mx plus b form where I can find the y-intercept and the slope. Now, the slope tells me the rise over the run, the up and down over the right. So we are actually going to go down 1 unit, because that's negative 1, and we're going to go to the right 2 units when we start making our slopes, because we have negative 1 over 2. Our y-intercept is going to be at 0, negative 5, because that's where we begin on our y-axis. Great. From here, we use the pattern from the slope to create more coordinates. I'm going to go down 1 over 2, and there's where another coordinate belongs. I'm going to go down 1 over 2 little jumps, again, create another dot. I'm going to do this pattern over and over again until I feel confident that I can draw a straight line. So for me, that takes a good number of coordinates before I try to draw my straight line. Once you feel ready, you grab a ruler, a straight edge, a piece of paper, somehow to draw a straight line on your paper or on your graph, and you're going to draw your straight line. End it with arrows. Make sure your teacher knows it goes on from negative infinity to positive infinity, or all the numbers. And we're happy. Now, the only other thing here is that we need to start talking about the vocabulary. The vocabulary we're dealing with is the y-intercept or initial value. But don't forget that we've already plotted that. That coordinate that we started with is called the y-intercept. It is also called the initial value. We know exactly where that is. The other coordinate that we're looking for is the x-intercept. So where this graph crosses the x-axis. This is also called the 0 of the function. So we have graphed it, and we have identified some key vocabulary. We have, again, our slope of down 2 over 1. We have our y-intercept or initial value of negative 5. And we have our 0, or our x-intercept, where the graph crosses the x-axis. Hopefully at this point we feel like we can master graphing equations, and we're going to be practicing that in class. See you in class.